Did you know that the decision between an electric or gas water heater can save or waste more than $500 per year on your energy bill? And that there is a secret technology that can increase efficiency by up to 300%? Today we're going to uncover the secrets behind this epic battle that happens every day in homes around the world. I'm going to show you data that the industry doesn't want you to know and reveal which technology is really worth it in 2025. By the end of this video, you'll discover which system can literally pay for itself in less than 2 years, why engineers are abandoning a technology that dominated the market for decades, and what is the new efficiency standard that is revolutionizing residential heating. I'll also reveal a strategy that can reduce your installation costs by half and an emerging technology that is making both electric and gas systems obsolete. Before we begin, please leave in the comments your name and the city where you're watching our content from. Let's start by exploring something that will shock you. While most people believe that gas water heaters are always more economical, recent data from 2024 shows that this reality is changing drastically. The energy efficiency of modern electric systems has reached 98%, while gas systems are limited to 80 to 85%. This means that practically all electrical energy consumed becomes heat to warm your water, while gas systems lose 15 to 20% of energy through combustion gases. But here's the first secret that the industry doesn't widely disclose. The real operating cost doesn't depend only on equipment efficiency, it depends on energy prices in your region. In many areas where electricity is generated by hydroelectric or renewable sources, electric systems can be up to 40% cheaper to operate than gas systems. Now let's tell how this difference impacts your wallet in practice. A typical family of 4 spends between $600 to $1,200 annually on water heating. With a modern electric system, this amount can drop to $400 to $800, depending on local energy rates. Traditional gas systems cost between $500 to $900 annually to operate. But there's a crucial catch that we'll reveal in a few minutes. Let's now explore what happens at the moment of installation. This is where many people make expensive mistakes. Electric systems cost on average $850 to install, while gas systems cost about $800. But here comes the important detail. Gas systems require adequate ventilation, which can add $500 to $1,500 to the project. If your house doesn't have an existing gas line, prepare to spend an additional $1,500 to $2,000. On the other hand, if you're converting from gas to electric, you may need new dedicated electrical wiring, costing between $250 to $900. Location also matters dramatically. Installations in attics can cost $200 to $1,000 extra due to difficult access, while installations in garages in cold climates need freeze protection, adding $100 to $300. Now I'm going to reveal something that few professionals tell. Heating speed is where gas systems traditionally dominate. A gas system can heat water 2 to 3 times faster than a conventional electric one. This means that after a long shower, you'll have hot water again in 20 to 30 minutes with gas versus 60 to 90 minutes with traditional electric. For large families, this difference is crucial. But here's an engineering insight that changes everything. Electric systems with heat pump technology are revolutionizing this equation. They use a principle similar to air conditioning, extracting heat from ambient air to heat water. The result's impressive. They are 3 to 4 times more efficient than conventional electric systems and can compete directly with the heating speed of gas systems. Let's tell about safety, an aspect where the difference is dramatic. Gas systems present risks of leaks, carbon monoxide poisoning, and explosions. Although rare, these incidents happen. Every year, hundreds of people are hospitalized for carbon monoxide poisoning related to gas heaters. Electric systems completely eliminate these risks, but present their own considerations, such as risk of electrical shock if poorly installed. Here's a fact that will surprise you. During power outages, gas systems with pilot lights continue working, while electric systems stop completely. But modern gas systems with electronic ignition also stop without electrical power. This is an important technical change that many don't know. Now let's explore something fascinating about durability. Traditional electric systems last 8 to 12 years, similar to gas systems. But electric tankless systems can last 20 years or more. almost double the lifespan. This means that over 40 years, you'll need to replace an electric tankless system only twice, while traditional systems will need to be replaced 4 times. I'll now reveal an industry secret about maintenance costs. Electric systems are incredibly simple. Basically, you have electric resistances that heat the water. Few moving components mean fewer things that can break. Gas systems are more complex with valves, burners, ventilation systems, and safety sensors. This results in annual maintenance costs of $50 to $100 for gas systems versus $20 to $40 for electric. Here's something fascinating that few consider: the real environmental impact. Let's tell the truth about carbon footprint that nobody explains properly. If your electricity comes from coal, an electric system can generate 2 to 3 times more carbon emissions than a gas system. But if it comes from hydroelectric, solar, or wind energy, the electric system has almost zero carbon footprint in operation. I'll reveal how to calculate the real impact in your region. First, discover the local energy matrix. If more than 70% of electricity comes from renewable sources, electric systems are environmentally superior. If it comes mainly from fossil fuels, efficient gas systems may be cleaner. This calculation changes everything in the environmental equation. Now let's explore the global trends that are changing this scenario rapidly. The decarbonization of electrical grids is accelerating. Countries are adding solar and wind capacity at record rates. This means that electric systems become environmentally better each year, while gas systems remain with the same carbon footprint. Let's tell about something surprising related to the complete life cycle. Manufacturing an electric system generates approximately 660 pounds of carbon equivalent. A gas system generates about 550 pounds. But during 20 years of operation, a typical gas system generates 15 to 25 tons of carbon, while an electric one on a clean grid generates only 2 to 5 tons. The difference is astronomical. Here's a fact that will impress you. If all residences change to efficient electric systems on clean grids, we could reduce residential water heating emissions by 80% globally. This equals removing millions of cars from the streets. The role of residential systems in climate change is much larger than most imagine. Here's something that few know about environmental impact. Although gas systems burn fossil fuel directly, the total environmental impact depends on how electricity is generated in your region. In areas with solar, wind, or hydroelectric energy, electric systems have significantly smaller carbon footprint. In regions where electricity comes from coal, gas systems may be cleaner. This is an important regional consideration that many ignore. Here's an insight that few professionals share. Return on investment depends dramatically on usage. Families that use a lot of hot water benefit more from efficient systems. If you use little hot water, the operational cost difference may not justify more expensive technologies. The rule of thumb is that families that spend more than $60 monthly on water heating benefit from high-efficiency upgrades. I'll now reveal specific strategies for different situations. If you're building a new house, install electric. It's cheaper and more flexible. If you're renovating and already have gas, keep gas, but consider high-efficiency condensing models. If you live in a small apartment, electric tankless is ideal. If you have a large family and large house, consider hybrid systems or multiple tankless. Here's a specialist trick to save on installation. If you're changing the system, schedule for low-demand periods. Installers charge less during winter months when there are fewer renovations. Ask for multiple quotes and negotiate. Many installers offer discounts for multiple installations in the same neighborhood. Let's tell you now about the payback period for each of the systems. The efficient electric system versus gas depends on local energy costs, but generally between 2 to 8 years. Solar systems pay for themselves in 5 to 10 years, depending on solar exposure and local incentives. Many cities are implementing codes that favor electrification. Some prohibit new gas installations in new constructions. Several regions have already implemented or are considering these measures. If you're planning long-term, consider these regulatory trends. You need to be careful so that errors commonly made by people don't end up costing dearly. The biggest mistake is choosing based only on initial price. The second is not considering complete installation costs. Error number 3 is ignoring available incentives. The fourth is not sizing correctly for your needs. And the last is not considering local energy costs. For small apartments or houses with limited space, Electric tankless systems are ideal. For new constructions or major renovations, always consider integration with solar systems. Technology is evolving rapidly. Systems that are the most advanced technology today may be surpassed in 5 years. Invest in technologies with upgrade possibilities and don't oversize for current needs if they may change. Now you have information that helps you make an informed decision. Remember, there's no single solution for everyone. Analyze your specific needs, local energy costs, available incentives, and future plans. The right decision for your specific situation will save money and provide years of satisfaction. If this video helped you understand this complex decision, leave a like and subscribe to the channel for more content about residential engineering and emerging technologies. Share your experiences in the comments and say which system you chose and why. See you in the next video where we're going to explore how smart homes are revolutionizing energy management.